Mercury, the smallest and closest planet to the Sun, has been a mystery for centuries due to its elusive nature and challenging conditions for observation. However, with the help of advanced spacecraft and scientific instruments, we have recently gained unprecedented insights into this enigmatic world. The first real images of Mercury have provided a wealth of information about its surface features, interior structure, and interactions with the solar wind, shedding light on the planet's history and evolution. Hello and welcome to our YouTube channel. Today, we're excited to discuss one of the latest developments in the field of space exploration, the first real images of Mercury and what we have discovered. However, before we continue, take a moment to like this video and subscribe to my channel. Without much ado, let's dive in. Mercury is the closest planet to the Sun, and as such, it has a unique set of characteristics that make it unlike any other planet in our solar system. One of the most striking things about Mercury is its size. It's only slightly larger than our Moon, making it the smallest planet in the solar system. Despite its small size, Mercury is incredibly dense, which suggests that it has a large iron core. The discovery of water ice on Mercury's poles was first suggested by radar observations from Earth-based telescopes in the 1990s. However, it wasn't until NASA's Messenger spacecraft conducted a detailed study of the planet from 2011 to 2015 that the presence of water ice was confirmed. The spacecraft used a laser altimeter to detect the reflective properties of the ice, which was found to be concentrated in permanently shadowed craters near the planet's poles. Distribution and properties of water ice on Mercury's surface. The water ice on Mercury's surface is believed to have been delivered to the planet by comets or other icy bodies in the early solar system. The ice is concentrated in areas that are permanently shadowed, such as the floors of polar craters. Recent studies have also suggested that there may be water ice trapped in shallow, sunlit regions near the poles that are protected by a thin layer of insulation. The properties of the water ice on Mercury's surface are still being studied, but they are believed to be similar to the water ice found on other planets and moons in our solar system. The ice is likely mixed with other volatile substances, such as carbon dioxide or methane, which may have been delivered to the planet along with the water ice. Significance of the discovery of water ice on Mercury for understanding the planet's history and evolution. The discovery of water ice on Mercury's poles is significant for several reasons. First, it was unexpected given the planet's proximity to the Sun and the high temperatures experienced on its surface. The presence of water ice suggests that the planet has a more complex history than previously thought and may have experienced periods of volatile delivery and loss throughout its history. Additionally, studying the distribution and properties of the water ice on Mercury's surface can provide valuable insights into the processes that shape planetary environments and how they evolve. For example, the distribution of water ice can provide clues about the mechanisms that transported and deposited volatile substances on the planet, while the properties of the ice can give us insights into the physical and chemical processes that have shaped Mercury's environment. The discovery of water ice on Mercury's poles is an exciting development in our understanding of this small, rocky planet, and it will undoubtedly continue to be a focus of research for planetary scientists in the years to come. Surface features of Mercury. One of the most prominent surface features of Mercury is its heavily cratered surface. This is due in part to the planet's relatively small size and lack of an atmosphere to protect it from impactors. The impact craters on Mercury vary in size from small bowl-shaped features to large, multi-ring basins that are hundreds of kilometers in diameter. These craters can provide valuable insights into the planet's geological history, including the frequency and intensity of impacts over time. Extensive lava plains on Mercury's surface. In addition to impact craters, Mercury also has extensive lava plains that cover much of its surface. These plains were likely formed by volcanic activity that occurred early in the planet's history. The lava flows are generally smooth and flat, and they often appear as dark, contrasting regions on the planet's surface. The presence of these lava plains provides important clues about the internal structure and processes of the planet, including its thermal history and the nature of its mantle and crust. Insights into Mercury's geological history and the processes that have shaped its surface over time. By studying the surface features of Mercury, including its impact craters and lava plains, scientists can gain valuable insights into the planet's geological history and the processes that have shaped its surface over time. For example, the distribution and size of impact craters can provide information about the age and composition of the planet's surface materials, as well as the frequency and intensity of impact events over time. Similarly, the morphology and composition of the planet's lava plains can provide clues about the nature of the volcanic activity that formed them, as well as the thermal and geological history of the planet. Not only Mercury, but also other rocky planets in the solar system. For example, the presence of a partially molten core may indicate that the planet formed from a relatively small amount of material, which in turn could provide clues about the early solar system and the processes that led to the formation of the planets. Similarly, the weak magnetic field of Mercury can help scientists understand the processes that shape the magnetic fields of other planets, including Earth. Comparison of Mercury's interior structure with that of other rocky planets in the solar system. Comparing the interior structure of Mercury with that of other rocky planets in the solar system can provide valuable insights into the diversity of planetary formation and evolution. For example, the relatively small size of Mercury and its partially molten core make it distinct from Earth, which has a much larger and fully molten core. Similarly, the lack of a significant atmosphere on Mercury means that it has been more heavily impacted by solar wind and other space weather phenomena, which in turn can affect its internal structure and evolution. The interior structure of Mercury is a fascinating topic for scientists studying the planet and its place in the solar system. By combining data from multiple sources, including spacecraft, observations, and computer models, scientists can gain a deeper understanding of the planet's internal processes and how it compares to other rocky planets in our solar system. Solar wind and its effects on Mercury. Mercury's proximity to the Sun and its weak magnetic field make it an ideal location for studying the effects of solar wind on planetary environments. The solar wind is a stream of charged particles that emanate from the Sun and interact with the magnetic fields of planets and other objects in the solar system. Because Mercury has a weak magnetic field and is so close to the Sun, it is exposed to a higher level of solar wind than most other planets in the solar system. The effects of the solar wind on Mercury's environment. The solar wind can have a significant impact on Mercury's environment, affecting everything from the planet's atmosphere to its magnetic field and surface features. For example, the solar wind can strip away the planet's thin atmosphere, which is constantly being replenished by the vaporization of surface materials. Additionally, the solar wind can cause the planet's magnetic field to fluctuate, resulting in changes to the magnetosphere and the charged particle environment around the planet. The solar wind can also cause changes to the planet's surface features, including the formation of unique structures, such as hollows, small, irregularly shaped depressions that may be the result of volatile substances being evaporated by the solar wind. Significance of studying the interactions between Mercury and the solar wind. Studying the interactions between Mercury and the solar wind is important for understanding how planetary environments evolve, as well as the potential for habitability on other planets. By understanding the mechanisms by which the solar wind interacts with planetary environments, scientists can gain insights into how planets form and evolve, as well as the potential for the development of life on other planets. Additionally, studying the effects of the solar wind on Mercury can help scientists better understand the broader context of space weather phenomena and their potential impacts on Earth and other planets in the solar system. The study of the interactions between Mercury and the solar wind is a complex and important area of research for planetary scientists. By combining data from spacecraft observations, computer simulations, and laboratory experiments, scientists can gain a deeper understanding of the processes that shape planetary environments and how they evolve. In conclusion, the first real images of Mercury have provided us with a wealth of information about this small and enigmatic planet. From its heavily cratered surface and extensive lava plains to its partially molten core and weak magnetic field, each aspect of Mercury's composition and environment has revealed unique insights into the planet's history and evolution. Furthermore, the discovery of water ice on Mercury's poles and the study of its interactions with the solar wind have shed new light on the potential for habitability on other planets and how planetary environments evolve. As we continue to explore and study Mercury, we can expect to uncover even more information about this fascinating planet and its place within the broader context of our solar system. With the help of advanced spacecraft and innovative scientific techniques, we are closer than ever to understanding the complex mechanisms that shape planetary environments and the potential for life beyond our planet. Thank you for watching this video on the first real images of Mercury and what we've discovered so far. We hope you enjoyed learning about this fascinating planet and the secrets it holds. If you have any questions or comments, please leave them down below, and we'll be sure to get back to you. Don't forget to subscribe to our channel for more exciting videos about space and the universe. Thank you again, and we'll see you in the next video.